Morning. Cheers, everybody. Hello. Look, little coffee cup. I'm trying to cut down on my coffee. So instead of my big cups, I'm drinking like 10 of these a day instead of, no, I'm kidding. Yeah, cheers. No, not an early stream. It's the normal stream. Just early for the Aussies who are now in daylight savings. I couldn't decide. Do I want to make it later and then have the overseas folks suffer, or keep it the same time and make all the local people suffer? So I decided to make all the local people suffer. Yay. Sorry Aussies, sorry Melbourne folk, sorry Michael. I know Michael wanted to sleep in this morning, so sorry. Yeah. So FFT for the win. It's not the best tuned FFT, as you might have noticed, but it's pretty good. It's okay. So, happy Bling Day. Yeah. How are you all doing? I hope everyone's well. Just had a bit of a weirdness happen. When I went downstairs to make a coffee, my computer, it had restarted, and so all of the hiding of windows and stuff and everything I got ready for the stream, everything just all over my desktop again. Had to tidy it all up again. So yeah, that was unexpected. I think it was something to do with Fusion 360 was updating. I don't know, maybe it crashed, or I don't know what happened, but yeah. But we're back. I think we're good. I hope my audio is okay. My YouTube stats are not updating though. That's interesting. I don't know what's going on there. What if I can refresh that? I'm always scared if I refresh the YouTube page, I'm gonna lose the stream. But okay, that's better. Now it's updating. Cool. Good. Okay. 1 hour before normal. No. Yes, 1 hour before normal. Right. Yes, it is early for everyone. It's earlier for everyone overseas. Same time as those in Australia. Oh my God, my brain is not working today. So we changed daylight savings the other day, which means it was 7:30 right now. No, it was 5:30 for us right now. Now it's 6:30. Whatever. Earlier for everyone overseas. Oh my God. Don't let me do maths first thing in the morning. I can never work out the whole daylight savings thing. There used to be a rhyme we got taught when we were kids about going forward, going backward, whatever. It's too hard. Give me some complex code, no problem, unless I'm on stream. But get me to work out if we go forward an hour or back an hour. Can't do it. Cannot do it. You know what else I can't do? I can't work out the maths for controlling Tanky with angles. Anyway, I'll get to that. I'll give you an update on Tanky. We're not doing Tanky today for a reason. I got other stuff I want to do today, and we've done enough Tanky. But Tanky's had an update. It's not quite what I hoped. I will grab Tanky in a moment and I'll show you. Set the grill out. Our grill's always out. We barbecue all year round. I've stood in the rain barbecuing. So yeah, fall back, spring forward, yeah, whatever, blah, 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 blah. We don't do fall, so, unless we fall. So yeah, just can't do it. Just make a time machine. You mean a clock? Is that what you meant? Wagon loads? Make a clock? So, did you like my little blingy stuff at the start? What I've done is I've set up my bling on the desk here under my camera, which is really high up at the moment because I was taking photos yesterday. I've got my really long lens on it, but it actually works out really well for this. So I've got bling sitting on, I've got some diffuser in front. Not that it makes that much of a difference. A little bit. And then bling, I've got a panel of bling sitting here. So they're made in panels, but only the top two are populated. The bottom one's not populated. And, ooh, warm. And then it's sitting on some black felt. not felt, some black foam, and there's a hole in the back. Why is there a hole in the back? Well, so I changed the USB on these. See, this is really hard now. I can't easily show you. Well, I can. I need to pull it apart. So bear with me 1 second. I'm just going to switch back to here. I need to unplug it. So I've got the USB cable going through a hole in the felt. These are really hard to pull apart when they're on a panel still. So that's my panel of Bling, and a last minute change I made, because something I never really liked on my design was the USB sticking out the side. Because with the USB sticking out the side, it caused issues on making cases, and do people want it coming out the left or the right, which means it's upside down or whatever. So what I did is I actually changed it and used some vertical USB connectors for the first time. So the USB goes up backwards, so that way you plug it in from the back. Because I have a case design for this that I'm thinking of, where this will be a front plate on a kind of thin, narrow little box, and so the USB will come out the back. The problem is my USB cable is quite a stiff cable, and which makes it a little bit hard. And obviously getting the cable in and out when it's on a panel is quite hard, because the panel's got no support on the end, as you can see. I'm gonna have to break this apart at some point. But at the moment I've had both my USBs plugged in for the top two boards that have got LEDs on them. It's been sitting on in front of my monitor, which is where that photo from my thumbnail came from. And I've had FFT running, different FFT styles, but just sitting there the whole time with FFT going while I'm working during the day, and it looks so cool. So cool. Anyway, so I don't want to pull it off the panel. But yeah, so this I'm hoping is the final board. And it's been a holiday in China, and Espressif have taken like 10 days off instead of the 3 days or whatever, which is fine, 3 or 4 days. Or I don't know how long the holiday's supposed to go for. And also my LED people. So I haven't ordered my LEDs. Well, I haven't paid for them. I'm waiting. They need to come back. And I've ordered my, I need special ESP32 chip, different ESP32 S3 chips than what I've got here right now in stock for these. So I can't actually manufacture these yet, although I've got some panels here. But these were built on my pick and place machine, double-sided and reflowed double-sided. But I've discovered a problem, not with my Bling specifically, but I discovered it with my TinyWATCH, and it's a real problem. And I will go into it in a minute, but I want to say hi to folks in the chat, which I haven't done yet, so I should just do that. So, Mr. England, good morning. Yumbo Prime, hello. Mako, hello. Moo3, Jeremy, hi. Ray, hello. Antonio, Atomic 14, Chris. Thank you very much, Chris, for helping me out, by the way, with the microphone stuff. That's what I'm going to talk about in a moment. Yeah. Okay, scrolling. Sid, good morning. Johnny, hello. And thank you, Johnny, for pointing out the image issues on my website. They are all fixed. I appreciate that. Life and Cycling, hello. Alan, hello. X Micron, Dutch Taurus, Wagon Loads, DIY in the Ghetto, hello. Okay, Dave Paul Jones. Where's the rest of my chat? Ooh, okay. Okay. Did you change your name? Markikson? Apologize if I got that wrong. Photochromax, hello. Okay, I think I've got everyone. Quiet stream today. Is that right? Have I only got 33 people? Maybe because it's early. Maybe it's too early for people. None of the Aussies are here, that's why. Because I should have done it later. Oh well. I can see Michael's online, but DPJ, Mako, oh, okay, right. Couldn't read what that was. Okay, cool. So, okay, I got some news first. Yes, Michael is here. Hello, Michael. We can start now. Sorry to get you up early, Michael, or earlier than you could have been. I saw the chat in Discord in the live stream channel last night, but I was already trying to fall asleep because I get up even earlier than you. So, where do I start? Hey, Dave. I might start with other stuff first, because it's going to become a, before I start storytelling. Okay, so, awesome news, Reflow Master Pro news. I have released, yay, version 2 of the Reflow Master Pro firmware. I've updated the website, new v2.0 firmware, and it is such a huge, massive, awesome update. Anyway, it's live now. The RMPs that I'm shipping as of yesterday, or the day before yesterday, I think, are shipping with 2.0 on it. And if you do an update from your device through the web interface updater, you get 2.0, and it's got wicked new features, including dark mode, light mode and dark mode for the web interface now, because John Raymond said, "Give me dark mode and stop hurting my eyes." And I actually like dark mode. Everything I run on all my computers in dark mode. So I'm not sure why I defaulted to light mode, but anyway, there's dark mode and light mode you can switch between. There's so many new features, including live tuning of bake and profile, both PID and classic mode. So this is tuning that you can do on the, like, live, real time, while your device is going, to tune stuff. Like it was a huge update. It took like so much work. MQTT publishing, so you can publish to your MQTT server your status of everything, including you can publish on intervals, which means you can log it to a database, or you can graph it, whatever you want to do. Anyway, it's a really big update, and I've already started on the next version, which I'm adding a new feature. Well, I'm not going to, although it's been discussed in the channel, until I get it working. Okay, my plan is to add a test mode, so a third mode. So you've got reflow mode, you've got bake mode for baking components or whatever, and oh, by the way, bake mode now has PID, something that was asked for by a few people. So you can use PID or my classic algorithm for bake as well as reflow, separate PID control. I'm adding a test mode where you can set up a sequence of bake steps for testing boards, like testing things like, hey Graham, good morning, like burning in boards. So it might be that you've got a board in there that's like running, yeah, and you can set it to sit at 40 degrees for like an hour, and then it'll go into like 60 degrees for an hour, and then 80 degrees for 20 minutes, and then whatever for whatever, you know what I mean? You can schedule, and it'll go through a whole test process of different heating and times for people who need to do temperature testing on their boards. It was a great idea. So Richard Fry was the one that asked for it, and so yeah, I thought it was awesome. So I'm adding that to my list of that stuff to do in the next version. And there's some other stuff as well, but what's going on here? My Discord's gone weird. Okay. All the names in Discord have disappeared, so I can't tell who's doing what, who's writing anything. Anyway, hey Christian. No, there's no pizza mode. No pizza mode. Sorry. So anyway, that's exciting. And yeah, okay. So the next thing is, I have. Let's just go back to here. I fully validated my new version of TinyWATCH. That was the revision 3. I did fix the touch I2C stuff and everything else, I2C. The touch is now on a separate I2C bus all of its own, and everything works really nicely. Hey Andy Mouse. And so, okay, before we get to the microphone situation, since then though, I've actually made another revision of the board because I couldn't help myself. And this new revision of the board, where's my thing gone? Oh my gosh. So when my machine restarted, it just rearranged all my freaking... Okay, where is it? Here we go. Oh, you gotta be kidding me. Okay, sorry, I'll get there. So I redesigned the board and I added 2 new things. I added, although I'm not sure it was a wise decision or not, we'll go into that when I speak about Tanky. I added a magnetometer up here. So we've already got 6 DOF of IMU here, so 6 axes here. This gives us another 3 axes, gives us 9 DOF, which lets you do any type of IMU calculation you need to do. I also realized that there's no persistent storage on here because storing stuff in spiffs gets stomped if you if you're not careful and you flash the chip. So I've actually added an extra, how much did I add? I can't remember. I think it's only, it could be 2 megabytes. I can't remember what size chip I ended up using. 2 megabytes of second flash. So you got flash inside the chip, and then you've got external flash for storing user stuff. So I've done another spin of the board, and in the process of doing that, I've actually made the board smaller. It's now 2 millimeters narrower and 1 millimeter narrower, which I know it doesn't sound like a lot, and 2 millimeters shorter. So it's actually quite significant compared to the size of the back of the screen in terms of fitting it all in. So, so the board's smaller and it's got more on it. I mean, I don't know what's left to add to the board. It's pretty much got everything now. I'm actually thinking of taking off the under voltage protection down the bottom here because there's a fuel gauge on there and you can constantly be monitoring the voltage of the battery, and the CPU itself can shut down the power switch, cutting off all the power coming out to the watch, other than the RTC and the fuel gauge, which are connected directly through to the battery, or through into VBus. Your code can just monitor the battery and then shut it all down. So I'm not sure if I'm going to keep that or not. That connector's not quite in the right spot. So TinyWATCH, yeah. So I haven't sent them off yet because JLC were closed for a few days. But I need to send them off and order some parts. Obviously I need to order that flash and order the magnetometer, but I've been playing with the magnetometer on Tanky and they're not great. I'm not using the same one that I've been playing with, but it's been a frustrating thing to get it calibrated. So I'm kind of torn now of how easy or useful it's going to be. But this led me to a problem, the TinyWATCH, which I now also have on my Bling. And so what is that? That is that I couldn't get the I2S microphone working. So this squeak. So I validated everything on the board, all of the I2C bus, all of the chips, everything was working great. Screen, touch, whatever. And I couldn't get any sound out of the microphone, and it was doing my head in. And so I ended up, I was chatting with Chris, Atomic 14, and because he's done a lot of work with I2S mics, and he actually checked that the pins I was using, I was worried that maybe the I/O I picked wasn't compatible, although it should be. There was no reason it shouldn't be. So he got the same microphone in a breakout board, got an S3 and used those pins, and he got it working fine. And then that code, exactly how as he got it, when I tried using it, it wouldn't work. And so it turns out that the mic was dead. And it was dead because I killed it because I cleaned the board. So like I went to the manufacturer's website, and you cannot ultrasonically clean the MEMS microphone, which is a problem because all my boards have to be cleaned. They have to be cleaned because I use a water-based paste, and the water-based paste has to be cleaned. It's not a no clean. If I don't clean it, it'll eventually corrode the joints. So it has to be cleaned. And so I swapped the microphone out with a new one, hot aired a new one on, and it worked great. And so then I thought, yay, I'm going to put some Kapton on the back where the hole is for the microphone and try to clean it. And of course the Kapton came off and I killed the microphone again. So I killed a few microphones. So the problem is, for something like the watch, I could make it, I could clean them, and then I could solder the microphones on afterwards. I could just hot air them on or hot plate them on because it's a single-sided board. I mean, it doesn't scale very well doing that. Right, as John by Prime says, that doesn't scale, and I'm having to manually put them on, right? And I have to put them on with flux still. I'm going to have to put no clean flux on, and it's potentially going to look a little bit messy. But the problem is Bling has got the same microphone on it, and as you see, the microphone's working because FFT's working. These haven't been cleaned. These are a double-sided board. I can't put the microphone on afterwards, after cleaning, because once the LEDs are on the front, I can't hot air or hot plate the boards anymore. So I cannot get the microphone on. So I have a bit of a dilemma in that it looks like for the first time ever, I'm going to have to move away to no clean paste instead of using my water-based paste, and not clean my boards before I ship them, which means potentially leaving flux residue on my boards, which I don't want to do, right? So yeah, it was a bit of a shock that the microphone died because of the cleaning. It didn't even occur to me. Apparently this is quite common, and people normally either solder them back on afterwards or they go use a no clean. So I need to find a new no clean paste, a multi-temperature no clean. So that's the other thing. I have to now use 2 different temperature pastes. So before I changed the USB, I could have used the same temperature on both sides. But the nature of the way the USB connects in now and its weight, I'm pretty sure if I reflowed this board the second time with the same temperature paste, the USBs will drop out. There's not enough surface tension on the way the paste is to stop gravity from just making them fall. The other components, there's enough pad size. And with the other USBs, the horizontal ones, there was enough surface tension to hold it there. I'd already tried that, but with these ones, I don't think so. So now I have to find new paste. Might put a tiny socket on the... No, Dutch Taurus. Really? So I'm going to take a beautiful board like this, right? And then stick a socket on it and put a plug-in... Firstly, you can't get a plug-in microphone. I'd have to put header pins or something like... No, sorry. Look at the stuff I design. I'm going to stick a board in this and have a board hanging off this to solve a microphone problem. No, sorry. Well, they don't specify. They just say don't clean it. Don't ultrasonically clean it. And and it's not just microphones. Pretty much all manufacturer that makes MEM devices say the same thing. No, it's not a nice solution. That's a nasty solution, Dutch Taurus. All good. You know what I mean? Like making a little daughter board to plug into it would make the whole solution ugly, right? I don't do ugly. So anyway, I'm speaking to a few different manufacturers, and I'm on the hunt for new paste, which means tuning new profiles. And anyway, it's a bit of a pain. It was an unexpected hurdle at this point, but I'm glad I worked it out on the TinyWATCH and not after I started production of Bling. What's interesting is so I'm not sure if you remember, but the very first Bling I made actually has been cleaned and it still works, and the microphone works. The second Bling that I made, that I realized now I had cleaned, the microphone didn't work, and I always thought it was a soldering issue on the mini module, but it wasn't. I actually killed the microphone without realizing it, and explains now why it didn't work when the first one did, and they were exactly the same. So like I could have literally destroyed hundreds of these boards by cleaning them and killing the microphones and never being able to replace the microphone on them. Like there would have been, you know what I mean? So I'm really glad I caught it now. Big thanks to the TinyWATCH. But otherwise, everything's working on it, and I've even started working on firmware for it. Do they light up during reflow? What? I would imagine the LEDs are light enough to not overcome. The LEDs are put on second. They're reflowed second, not first. So I can't do it the other way around. I can, but I don't want to. I need to test the board works before I put the LEDs on. So I do one side, I do all the components, then it gets thoroughly tested, because once it's done, I can't rework it, right? So test all the components. The only thing I can't test is obviously the LED array, but and then once the LEDs
Mako says hello, Cian and chat.
Hey Mako. So yeah, it's got to be components first, unfortunately. Anyway, it's going to be an interesting thing. But the good news is I can do double-sided workflow now, which is fine. And for things that don't have a MEMS device, it's not a problem. I can keep using my water-based. I can keep washing it. That was kind of long-winded, wasn't it? But yeah, so TinyWATCH, I've started on firmware for it. And of course, I've dug myself a hole that has gone well beyond my skill set. What? Are you going to make your reflow profiles include a number reference to the type of solder paste? My reflow profiles for my oven, my big oven, have named profile. I name whatever the profile is. So I name them specifically. And some of my profiles I've got for the paste and some of them I've got for the board. Some of my boards need a different profile than just the regular same paste one because of thermal mass of the board. So I think I can store up to 40 different paste profiles on my IN12. So most of them are unique. Not all of them are. Some of them I just use the same, but some of them are unique. So Tanky is not ready to be plugged. Why is my phone so hot? Is it trying to connect? No. So I upgraded Tanky. Let me grab Tanky. Tanky works, but my upgrade's been a bit problematic. So no, we're not playing with Tanky today. So what I did is I added two things on Tanky. Hopefully this won't fall apart if I hold it up. You might not be able to see. Okay. I added a magnetometer, so like a compass, and a little OLED display to the Pi, so I can see what the compass thinks it's seeing. And I wrote some code that, when rotating, it uses the compass heading. So if you say left 45, it can rotate approximately 45 degrees based on its current heading. And it mostly works. The problem is the process to calibrate the magnetometer is awful, at least with this magnetometer. and it's not accurate. And so I might get, out of a full 360 degrees, I might get 2/3 of it to be pretty accurate. Like I can go 0 and I can go here and it's, 92 or, 88. And then I can go here and it's about like 178 or 176. But then I'll go to here and it'll be 270 already. And I'll go to here and it'll suddenly jump to like 360. Like there's always a region in the calculation that's wrong. And so this is using a QMC 6310. It's not a coding problem, it's the way it has to be calibrated. The problem with the magnetometer, so what you do is you power it up, you put it into calibrate mode, and you need to rotate it on the spot. And it calculates everything and it saves it. The problem is, by its nature, it's affected by a magnetic field. So ideally it needs to be calibrated away from the tank. How do I calibrate it away from the tank when it's going to be powered running off the Pi?
Chat is disconnected.
Ooh, why is chat disconnected? It's back again. That was weird. Okay. Hard or soft? Hey Andrew, I don't know what a hard or soft iron calibration is. There's only one way of calibrating. So the library, it's a Core Electronics board at one of their Pico dev boards. And the library for it is pretty cool. Yes, once calibrated, I can, it loads that calibration data and it's repeatable every time, but if the calibration isn't perfect, it just doesn't run properly. So there's a section of the rotation that just doesn't run. The other problem is on the Pi. Could you get a second Pi and calibrate somewhere else? No, well, yes, except it still can't be next to the Pi when you do it, because there's metal around, right? So it influences the magnetic field. And so what I really need is a long I2C cable, which I don't have. So I'm gonna have to either make one, I don't have any connectors here, any SH connectors, or I need to just buy one, like a long one, so I can get it right away from the magnetic field as I do it. So buy a third, ha ha ha. Plenty of Pis, that's not the problem. So, well, it's not just that it's metal, but they give off an EM, electromagnetic field, right? So all electronics do. So that's my next thing I need to try. But even so, what I found is it's not fast enough. The Pi, okay, the Pi is plenty fast, but using Python, using the way the library works for the motor driver and all the other things that are running, especially MQTT, I found that I can't get it to read the compass and compare the values fast enough. You're supposed to be doing a 10 millisecond delay between compass reads, and that plus the tiny small blocking of MQTT and stuff causes a problem where it can skip and miss things. So my next thing is, so the two things I need to try are, I need to find a better way to calibrate it. Don't you need to calibrate in this working environment? No, it's not going to pick up electromagnetic stuff that's a meter away. I just need to, like right now, my longest cable is this long, right? So firstly, it's really hard to spin it exactly on the spot because the cable's in the way and it twists and whatever, but it's also right next to the Pi. I need to get a longer cable. I need to see if I can calibrate it better. But when I was looking for something else and looking for cables yesterday, I found this. I don't know when I bought it. It would have been a long time ago. This is an Adafruit board, and this is actually a 9DOF board. It's got a STM parts on it. So this actually has a magnetometer on it as well. I don't know what the calibration process is like, but it's got STEMMA QT connectors on it. So I could look at swapping out this one, the one I'm using now, with this one, if it's easier to calibrate. And I just have to look at Adafruit's drivers for it. Cut the current cable in the middle and add wiring by soldering ends. Yeah. Anyway, So there's a few things I need to do. The other thing is I need to have a look at starting a separate thread for the magnetometer that I can be reading that independently, or start a separate thread for the MQTT stuff, so I don't have the two of them competing and blocking each other. I need to be able to be checking the heading much more often. But anyway, I've updated the firmware, so you can type in R or L and then any value from 0 to 360. 0 is stupid. To 360, well, that would also be stupid, and it'll actually use the compass heading to rotate the tank, and it does. It tries to rotate, but often it'll miss it. My fuzzy logic isn't enough to, if I make it too wide, it could be 5 or 6 degrees off. It's supposed to be accurate enough to get within 2 or 3 degrees, and I visualize all of that on the little on the OLED, which is only black and white, so it shows which way it's currently heading, like a little compass, and where the target is, and you can actually see it trying to rotate towards the target. So I was hoping, like I spent like 2 or 3 hours on it yesterday, I was hoping that would be ready to play with today, but it's just not there. And it was spinning around, like it was trying to rotate, and it kept skipping, so it'd go again, skip, go again, skip, and I can't remember what I did. I accidentally, instead of stopping the code, which kills the motors, I killed the terminal session. And because the terminal session was gone, but it didn't kill the motors went to 100% speed. And the tank was on the ground going, like full on, spinning so fast, right? Because like when we were playing the other day, that was only running at 25% duty cycle, right? It was running at 100, going like spinning around, and I'm freaking out going, oh my God, and the noise was insane. Like they're really loud, these things. And so like I had to quickly get another terminal session up, and I had to log in and start the script up and then kill it to stop the motors. Oh my God, I went into panic mode. It was hilarious. Like it was just, you know what it was like? It was like, oh my God, the building's on fire. Oh my God, what do I do? What do I do? What do I do? What do I do? The building's on fire. What do I do? Like, get out. Like I couldn't, I suddenly had that whole, I don't know what to do to fix this. It was probably only like 2 seconds or 3 seconds that I did that, but it felt like 5 minutes, right? That I was sitting here going, I don't know what to do, and it's going. Anyway, after I got it stopped and I went over there, you could smell the motors. Like nothing melted, but you could really smell the motors. They were like running full on. If you pick it up, I couldn't pick it up, and it was going so fast, I didn't want to grab it. I didn't want to actually try to grab it and then get my fingers caught or rip any cables. I just wanted to stop it properly. Anyway, didn't get that on camera. So I did make progress. I'm still working on it. I want the tank to, and the other things I got an I2C, another module, a time of flight sensor, and I got a little an I2C based servo controller that I can plug the tilt and pan camera into. So technically we could control the rotation of the camera. So that way, like if you want to go backwards, you can rotate the camera around to look backwards and then drive and so forth. The other thing that I thought might be really cool is, how cool would it be you could use the camera rotation to set the rotation. So you could rotate the camera 10 degrees and then the tank, and then you could say match camera and the tank would rotate 10 degrees. That's another cool idea. Well, it is PWM for servo control, but the PWM channels on the Pi are completely taken by the motor drivers. So I need a separate PWM chip, and I need it to be I2C because I don't have access to any more header pins. So the only thing I've actually got access to after the motor driver is on really is the I2C bus. Hey Clem. Can we see anyone else saying hi? Maybe. Straight up Kiki. What? Kiki in the nuts. Okay. All good. No worries. Anyway, so Tanky's had progress, but I thought we'd give Tanky a rest today. Yeah, I need to sort out the... I'm actually working with the Core Electronics guys to work out how I can get a better way to calibrate it. But my fallback is that I've got this version, and there are lots of other magnetometers. But because of it... Thanks, Mako. Because of this whole issue yesterday, I'm now... Although I've chosen a different magnetometer for TinyWATCH, and I've actually found a module that Adafruit...
Wagon says, can you know how to find a dock to the charging station?
There is no charging station, so no, not really. And there's no way to build a charging station for it. The battery is a physical connection that has to be unplugged and charged with a proper charger. So, yeah. Don't need that. Like, yeah, I don't think so. Anyway, so I found an Adafruit board that uses the same magnetometer as the one I've chosen for this. So I'm going to order one of those and have a play with it first before I commit to the PCB. Because if it ends up being a shit experience on the watch where you need to calibrate it first and you have to do some stupid spinning around thing and it's not accurate, then it's a waste having it. Like I didn't want to put a bit of hardware on there that either is hard to use or doesn't work properly. Okay, so back to Bling. So I need to test. There's a few things I need to test, and I'm gonna have to. Let me just grab an SD card out of my Reflow Master Pro. Bang. Okay. I need an SD card that's populated so I can test it. I've not tested the socket. I've tested the buttons and I've tested the microphone and obviously the LEDs. I've not tested the speaker. Is that not going in? Why is that not going in? Okay. So SD card goes in the back, just like that. Socket there. We've got battery connection and speaker is now a JST connector at the back. So I need to test those and make sure they work. And I actually have a speaker here somewhere, if I can find where I put it. Okay. I hope I got the pins the right way around, but I got a speaker that that's got a JST connector on it. One of these ones I got from Adafruit ages ago, and this is actually what I want to use in. So what I want to make is like a little, whether it's a little clock box or whatever it is, that has a bling on the front. You got access to the buttons on the side of it. And then either in the inside of it, either facing up or something, will be like a speaker like this inside the box that is plugged in. And so you've got microphone, you've got like sound, you've got whatever else with a bit of acrylic in the front. I need to design all that still. I'm going to plug a speaker in. Positive. Oh, good. Looks like I got the orientation of the speaker connector correct. And I also need to check the battery, so I need to grab a battery. So I'm just plugging this in now, and then I'll put it back on the thing so we can see it all. Whoa, okay, I plugged the battery in, and that's working. Yay! Ba, ba, ba. So, and I just want to, I'll plug power in now just to check that the battery charges. So, there's no LEDs on the back right now. But if I plug the USB in, we've now got power LED and a charge LED. Two LEDs, as you can see. That one on this here is yellow or orange, but they both look red. Okay, so battery works, charging works. So I'm just going to unplug that, and I'll just take the battery off. For now, because we know that works. So now I want to plug this in over here, and then we can just switch to there. So, well, I know at least this button works because that changes mode. It changes mode of the FFT display. Put that back on there. Okay, so now I need to check the SD card. I started working on a bunch of code for this a while ago. This does some Wi-Fi stuff, and I believe it does SD card. I don't know what state I got this to. Probably not much. Does an SD begin? Okay, I might just need to load some file open. Just need to find some SD card testing. Waterfall visualization. Well, other people can do that. Did he print a woofer? What? Fire? What? Came for LEDs. Hey mate, how you doing? Well, there's some LEDs for you. Hang on, I need to, okay, so I'm sure I've got some SD card testy stuff. Maybe I'll just...
Mako says, Cian, could this animation be a bit more wide, touching the right and left sides?
A bit more wide. You mean zoomed in more? Oh, you mean on the display? No, because they're even steps. So if I take it further on the display, then they're not spaced out properly, if that's what you mean. And that's 16 channels. So I've got an 8-channel version and a 16-channel version. I mean, I could make maybe an 18-channel version, but it's a lot of work just to get 2 extra little dots in on the side. I think just with the brightness, I think that one looks better. Anyway, well, there's more than 2. There's I could probably get an extra 6 on there, but yeah, someone else can code that. That's fine. I don't need to code that. File examples. I'm just going to grab the ESP32 SD card. Where's their SD card? SD card. Test. Now I don't remember what. Let's go to Bling. Get the schematic so I can remember what pins I used. Oh, excellent. Didn't pop up. Okay, so SD. There's 21. Okay, so let's set up. Okay, so let's just flash this and see if it reads the SD card. Hope it does. No, Bling can't run my logo code because my logo layout is a completely different. It's not a a rectangle. And there's also not enough LEDs. My logo is 64 by 32. This is 40 by 8, so can't really run it, no. Oh, wait. Okay, that worked. Failed to open for reading. What? Oh, it worked. Loaded. These are my Reflow Master Pro stuff. So, Mito list. Yep, okay. I don't know what the failed to open, what that is. But it looks right. So the SD card works. Yay. So what else do we need to test on the board? Oh, speaker. The speaker. How are we going to test that? Let's go back to my FFT example. Maybe we can go I'm going to add some code. 1 second. Okay. Where's my TinyWATCH stuff? Okay, I'm just going to add some buzzer code. If I can find it. Sorry, 1 sec. Lib. No. Open with. Okay. New tab. Buzzer.cpp. And new tab. Buzzer.h. Okay. And main, open. Okay, include buzzer. I wonder what my, I can't remember what my buzzer pin is. Can it Bling accept and work as an I2C display? No, it's not an I2C display. It's got a full everything on it. It's a, why would you do that? It's got everything. So there's a version of Bling, just to remind folks, there's three Bling versions. There's the full version that's got everything on it in the kitchen sink. There's a Bling version that has headers on the back for one of my tiny boards, plus some stuff broken out. And then there's also a Bling version that is just going to be the LEDs with 3 pins at the back that you can connect up as a screen and do what you want with it. So you can choose from everything down to just a screen, or just a display that you can solder on and do what you want with. So you can turn one of those into an I2C device if you want to. That's up to you. Okay, what was it doing? No, it's not a kit. Okay, what number is my buzzer on? Ooh. Hello, buzzer? Where are you? I haven't cleaned up the schematic yet. Stuff's all over the place. Oh, it's not a buzzer. What am I doing? It's not a buzzer. It's I2S. So that is pointless, what I'm doing right now. Delete. See, you're an idiot. Delete. And I don't want that. I want open. So there's no buzzer on there. It's got an I2S amplifier with a speaker. So I want, where's my, I don't remember what I called it. Sorry, I'm looking for, I wrote some code that plays, like it does internet radio. And I don't remember what I called it. God, I hate that. So many projects in my Arduino folder. Okay, maybe if I look in order of when I last changed stuff. Maybe this one, will that work? Sorry, I'm just hunting for code. I know that's boring for everyone. Yeah, this should work. I was going to make sure that my pins are correct. Okay, so amplifier. 1, 2, 3. Whoop. Okay. Could be. Okay, let's see if this works. I think your dragon just woke up. Oh yeah, downstairs. Yes, it did. Oh, cold coffee. See, I got a small one and I'm still got cold coffee. Why does it take so long to compile? Yeah, it's really busy. It's a busy road. Hey, Dave. Look how long this is taking to compile. Okay. PS RAM ID read error.
Hello, Sayon. How's it going? The speaker is good.
Okay. Oops, that was upside down. Speaker was facing down on the thing. Did everyone hear that? Hey, Andy Calloway. Yeah, okay. Folks heard it. I wonder if I can get it to play a stream. Some music and get in trouble. I don't know if any of these will work. I want it to play streaming audio. So I started working on an actual web radio code for it, where you can use the buttons to set what radio station, and it displays on the screen what the station is, and then it uses. Let's see if it works. Wi-Fi association refused temporarily. Okay, well that's dropping out. That's not doing so good. Yeah, but the speaker works. Anyone know of a good streaming station that might actually not? It's not liking the PSRAM though. Barely. At least I'm not going to get a, what do you call it? A strike for that. Copyright strike. Wonder why it's not recognizing the PSRAM though. It's coming up with some error about PSRAM. Okay, so it's working. It's actually quite loud. Okay, I'm just getting rid of it. I don't want to get in trouble. No. Jeez, that speaker is loud. Okay, it's gone. Okay, speaker works. Yeah. I set you a Yumbo Prime. You're a moderator. You can post a link now. Can you play some Perica? I don't want to get... Anyway, so that's working. I've put that back on again. So what else do I need to test on the board? I think that's... I think that's everything. So sound in, sound out. SD card works. I should check that the RTC, it recognizes the RTC. So, no, not examples. Actually, I can probably go examples. So let's just check the RTC. Yes, you can play MP3 from SD card or WAV. It's one of the reasons I put an SD card on there, is so you can store audio on there if you want, or you can store images or whatever to load up, display on there. I thought a GIF player would be pretty cool for. It's a you know, you'd need GIFs that are that particular size, but okay. Let's just make sure the RTC bus is working. What is my interrupt pin? RTC interrupt. 7. Okay, we're going to set it. So what's the time? Well, it doesn't matter, whatever the time is, it's irrelevant, because I'm just setting a fixed time, not getting it from the internet, and then setting an alarm that will go off in 1 minute. So let's check that. Hey Bruce. Yeah, I saw your picture of your latte. That's pretty snazzy, look at that. That's Bruce's latte. Did you make that yourself, or did someone make it for you? I'd love to learn how to do that, do stuff like that. Latte, oops. Okay, so, okay, it found the RTC, it's good, it's at the time, and in 1 minute it should just log the alarm. So it's weird, the RTC, you can only set alarms based on an hour, right? But it's a match of an hour, and then you can give it the minutes in that hour, which means like I can set it to do an hourly alarm at 25, which means every time it gets to 12:25, 1:25, 2:25, the alarm will go off. See that? So 1 minute later, the alarm went off. So the RTC is working. Or you can do a day alarm, or whatever, a weekly alarm. But the way you do if you want an alarm in 30 minutes, you do an hour alarm, and then whatever the current time is, 30 minutes plus 30 minutes, and then it'll do, anyway. So that's not a Timmy's. What? Who? What? What are you talking about? Okay, no problems, you're my Prime. Okay, so that's everything on the board. Like, I can't think of what else it needs to be tested. I know the I2C bus is working because we just tested that with the RTC. And obviously the power, I know the power is working for the LEDs. So the LEDs have a separate power. So they run through a separate LDO. So there's the FFT example working right now, right? But if the power pin is 6. If I set the power to low, which obviously you can do this in your code however you want to, and run the same example, there'll be no LEDs. Did capability. What? End foo did capability. What? It works at full brightness on all LEDs, but it's going to make it very hot. That right now is running on, I think it's temp. So right now you see it's not working anymore because I've actually set the power. The board's running, but I've turned the actual power to the LEDs off. So in code, you can do that. Like there's no point, because even if you have nothing displayed, if the power to the LEDs is on, there's 320 LEDs on there, and each one has quiescent current. You're just going to be chewing power unnecessarily and keeping the board warm. So right now the where's the brightness? Brightness here. That's set to 10. 10 out of 255, right? I can do it. I'll do full brightness, but it's insane. I don't recommend it. You'll end up melting your board if you do that. So, there'll be a warning on the purchase page that'll say, just don't do it. You don't need to. Look how bright they are. Like, these LEDs are really bright. I can actually run them at 5 in brightness, and they've still got full color fidelity. Look, I mean, that is just, whoa. I mean, that is so bright here, it's not funny. Look at how it's flashing up when it gets to the higher colors. Yeah. So the answer is yes, you can. The limitation is, well, no, because the regulator can put out more than what the LEDs need. They're quite low power LEDs. Okay, that's at 5. 5 out of 255. I mean, that is, like, if you were here in real life, like, I know the camera blows it out. That is super bright. I would never need it brighter than that. And as you can see, you can still see all the different color graduation. Like, red is red, orange, yellow. Like, that's as low as I can get it. If I take it any lower than 5, you start losing some of the color channel data. Yeah, the reflowing the board's limitation. There's the LDO on there can provide a burst of 700 milliamps. The highest I've ever, not using this, like actually being silly, the highest I've ever seen current draw for the LEDs is about 360 milliamps. So there's stacks of headroom, but you just don't want to do it. It's not the, it gets hot. So if you consider the board, maybe I'll turn that, actually I'll turn this light on. Okay, so if I take this off, I'm just going to turn this over just for a second, if I can. I'll unplug it. Okay, so if you consider how many LEDs there are on the board, right, 320, and how packed in the components are on the back, and it looks like there's a lot of space, but I mean that's all power plane and routing for the LEDs, right? The board gets hot. Like, you're not going to burn your fingers, but the board gets, you know what I mean? So the issue is not, can it deliver enough current? The issue is, you're going to melt the board if you're not careful, because it's pretty packed in, and it's So also, I've not done any tuning on the RF yet. I've not done any matching on it, and that was working great on the internet just then, right? I mean, the first station clearly was dropping frames, but the second station was working fine. So I'm hoping that tuning the RF is going to be pretty simple on this. Yeah. So I'll just get a closer look on that for those that are interested. Oop. Oh, not that I can. Anyway, is that in focus? That light doesn't do it any justice. Let me just rotate the light. No. It's too hot. Anyway, LEDs have a much lower current limit than the usual. Yeah, way lower. These are, well, a normal WS2812 is like 12 to 20 milliamps per channel. These are 5. So they're already lower, and they've also, these particular LEDs have got a really nice diffuser on them. They're not the standard ones you get from AliExpress or the usual suspects. These are a taller LED, and they've got a white, opaque, like, you know, a semi-translucent cover on the top of them, so that they're quite tall. They're a little bit taller than a normal one. They're 0.75 millimeters high, where the other normal LEDs you can get, the 1010, are they're about 0.45. So that little bit extra really helps diffusing what causes all the heat. Yeah, you're pumping in, you're spreading out 300 milliamps. I mean, an LED gets warm, like that's how it gives off light, right? And you're pumping, you know, a lot of current through the board on top of what the board's already using, right? So if you're running Wi-Fi and you're, let's say, streaming audio from the internet, for argument's sake, right? Well, you're already, just the ESP32 alone, plus the extra peripherals for it to run, is already sitting at 250 to 300 milliamps of continuous current going through the board. And then the LEDs, if you're going to add, you know, be a bit silly and add another 300 milliamps, you've got 600 milliamps, like that's 0.6 of an amp of current running through a board that is 99 millimeters long and 22 millimeters high, right? I mean, that's pretty insane. I actually did a version of the board that was a 6-layer board, so I could have additional power and ground planes for it. But they're too expensive to go 6 layers. This is still on a 4-layer board. The bottom one, yeah, there's no LEDs on the bottom one. I didn't want to waste LEDs. This one, the bottom one doesn't have an ESP32. I didn't want to waste that, or a microphone, or some other things. But I populated because I was testing the manufacturing of it. So I was using all 3 boards to tune my placement. Hey, Rota. Hey, these are LEDs, I guess, with 5 milliamp per channel. Well, these aren't SK6805 and they're not SK6814. I actually don't know what controller chip they're using inside it, but it's WS compatible. Wow, it is bucketing outside. I can hear all the rain running off my roof down the whatever that thing is called. Hey Nathaniel, what is this device product for? It's for whatever you want to do for it. It's a 320 LED RGB LED matrix board with all the bells and whistles on the back, so you can do what you want with it. Including cook eggs with it, maybe, if you're not careful. Hey Liam, sorry, a lot of people joining in. Hey Beata. Yes, it's bling, lots of LEDs, bling bling. Sorry, just looking back, have I missed anyone? Mad Chicky, hello as well. So I don't really know how much, like these can't be 5 milliamp per channel. I don't know what they are. Because I can't, as I said, I can't, with all of them on white, at full brightness, I can't get it above about 300, I think it's 360 or 355 milliamps. So 355 divided by 320, that's only like 1.1 milliamps per LED. So I don't know what's going on there. 1/4 watt RGB. I don't know what you mean by 1/4 watt. That's not how LED is done. Maybe it has a global current limit per LED. It might have. Again, it's the supply is secretive, actually, of what chip is inside. They're actually a bit of a painful supply to work with, to be honest with you. And the LEDs are expensive. They're double the price of any other 1010 addressable LED that I can find. And I've got boards here using cheaper LEDs. So the reason I'm using these LEDs though, is apart from the fact that I think they look a little bit nicer. You can tell the difference in real life. Like if I take a board that's got the other ones on it. I have one. Right, so here's a board. No. Right, so this you can't tell through the camera, right? So these are two different LED types. Through the camera you can't tell because the way it kind of blows things up. But I can see the insides of these LEDs. They look like a normal LED, you know, they're slightly yellowy top, and if you look closely you can see the insides, you can see the guts, you can see where the chip is, and it's got like a black dark area inside it, and when they light up in each channel you can kind of see that the red LED is slightly to the top left and the blue ones are you know what I mean? Like a normal LED, normal RGB LED. But these ones you can't see inside, which makes it really hard to place them, really hard to work out what orientation they are. They're way more diffused, and as I said, they're also a bit taller. But the reason I'm going for these and not using the cheaper ones is the fail rate on these cheaper ones is much higher. Meaning, if let's say I build, I don't know, I'm just plucking a figure, I build 1,000 of these bling boards, the number of bad LEDs I'll get during that is much higher. This supplier is claiming one bad LED per 5,000. And my experience with these other LEDs in 1515 and, or at least, okay, 1515 size, is that the failure rate on them is more like 1 in like 600, okay? No, these are all pick and placed. Not hand placing those. It's like 1 in 600. I can't afford a failure rate of 1 in 600 when I've got 320 on a board, because I can't easily rework them, right? I mean, that'd be crazy. If I had to rework 1 out of every 2 bling boards I make because there's a bad LED, I might as well just chuck the board out. Like, it's, you know what I mean? It's a real problem because of the double-sided nature. So I'm going for the better LEDs that they look a bit nicer in real life, and the fail rate on them is much, much better. 5-bit current limit from 12 milliamps on top of the 16-bit. That's pretty cool. Do you know what LEDs are actually using that chip though, rotor? EC10 are working with the... So there's, like, what size are they? Oh, geez, the sign has a few bad colors on them. No, it doesn't. Oh, you're seeing a reflection. It's a reflection. They're not bad colors. All the LEDs are fine on the sign. Unfortunately, the angle of the camera looking at the logo, it's reflecting bits of stuff from my skylights on the ceiling. Hey Loki, I bought some EZ10, which are 1.1 by 1.1. Okay, cool. I'll have a look at them. Anything with smaller LEDs, a smaller current draw is good. Thanks for that, rotor. On the underside of the U. What? No, that's a reflection. Trust me. If I turn off the logo, it's reflection, you see? There are no bad LEDs on there. Yeah, we're gonna have to do the trails again. So you can see the reflection there. It's unfortunate. There's nothing I can do. There's nothing I can do that isn't going to look super ugly on the wall, right? Or on my ceiling to try to stop it. So the 16-bit per channel and the additional current setting. There might be something like, there might be some other libraries out there. Like, do you remember those? I'm sure if you remember, ages ago I got some 1212 LEDs that were 16-bit. And of course there were no libraries for it, but I ended up hacking a library to get that working. I mean, it shouldn't be too hard to change one of the libraries. On the bottom of the M, bottom of the M. No. I'm telling you now, all the LEDs are fine. No, they're all fine. So, I mean, you know, that you'd have to go through it. There's a lot of different libraries out there now for RGB LEDs, but it shouldn't be too hard to get support in it for 16-bit. I like this. The 16-bit ones were interesting. There was much nicer color fidelity. Second row middle pixel. Second row on the M. Oh, no. What you're seeing is there's a screw there. Right. So that dot, that's the screw holding the acrylic in. There's one there and there's one on the top of the U. So the camera's looking down, and so the screw it's interfering. Trust me. it's all good. Yeah. So I've been playing with a design for a slightly bigger, not that much bigger, slightly bigger logo, but with almost 60% more pixels to get more fidelity out of it. I haven't actually, like I've started playing with the design, but it's a huge amount of work to do, and I really don't know if I want to go down the road of, like, everyone remember, like, I can't, panels that big I can't pick and place, even in the Juki, right? But I'm trying to design one that comes in parts, that I've got a few reusable parts, but where all of them can be pick and placed. Because that was a nightmare. Do you remember I hand placed them all? And then I had to reflow it. Remember I was holding it on the hot plate and having to move it around? Burnt my fingers. No sound. I think sound's working. Maybe you turned your speakers off. Sound is right here. Okay, cool. Okay, so this is good. I need to panelize this version. I need to add the, so I'm not sure if you can see it. There's no mounting holes. I put these half cuts in for mounting support. And so this board needs to be panelized, and I need to do the same thing, put the half cuts in. It's also a double-sided board. And then this one here, well, I actually made this smaller. I'm not sure if you can see, because it's got no buttons, it's got nothing else. But I might actually put it back to the normal size. I don't know. And I figure people are going to want to chain them, although it's a really bad idea, right? So right now there's no out on any of them. I can't do an out on these, and I guess I technically could on this one. I don't want to give people the ability to literally cause a fire. So, voice Dave Jones. Okay. I don't think that's going to work. You still had sound. Restarting solves the issue. Really? I was silent? Okay, I don't know what that was about. Yeah, I don't know. Braxis? Hope I got that right. I've never met Dave in real life, no. I've chatted with him on the internet, but not met him in real life, no. Flapping in the breeze. Winner, winner, chicken dinner. Anyway, I don't know. I don't think I'm going to add a way of chaining. You can't, they're not, like you can't make a whole array out of them. They don't line up. I can't get them to line up. Like, there's no way, trust me, there's no way I could get them seamless to each other. The pitch is too small. So you couldn't make a bigger panel out of them anyway. So I know what the LEDs are. You don't know what the LEDs are. So, and for the time being, I'm not going to say who I'm getting them from because they're limited supply. And as it is, I've had to wait over a month to be able to get my order in for them. So, yeah. But there are plenty of other LEDs out there that you can use instead for your own stuff. For me, it's different because I'm manufacturing these. I need the reliability of them. Okay. So I'm still like 10 days away at least. It's not about being a businessman. It's just they're in short supply, and the last thing I'm going to do is jeopardize my availability to release my product. What's their current brightness? Look back. We discussed all this before, or someone else can answer. Nathaniel, it was we already covered that on the stream. So I'm about 10 10 or 12 days out from being able to actually go into proper manufacturing because of the Chinese holiday. So that's cool. So TinyWATCH. Yeah. I'm going to, I started trying to work out how to make a case for it, and I can't get my mind around cooperation with cosplay parts. Not sure what or where, but would be awesome wearables. Yeah, I mean, it could be. I mean, as they run off battery, sound out of activation and audio out. Plus the SD card means that you can store stacks of data on there. And there's a STEMMA QT connector on them if you want to add or chain a whole bunch of I2C devices if there's anything else you want. Temperature sensors or, I don't know, whatever. Sorry, I was saying that with, I bet you it didn't reopen, did it? Yeah, my Fusion crashed. Awesome. I've been playing with, trying to work out in my head how to build a case for the TinyWATCH, and I really can't get my head around how to do it. Like, it's got to be two halves clamped like together, and obviously one that the screen sits in, and then the other one for the rest. But there needs to be buttons that push. So these buttons aren't designed to be pushed directly by the user. They're designed to, you push a button on the case, which then pushes the actuator, right? Because they don't stick out far enough. Intentionally, I didn't want little holes with little buttons sticking out the side. So something that would be kind of, you know, flush that you could click, push, and that part's got to be on the bottom section that the board sits in. And then obviously the battery's got to go in there, and anyway, it's just going to be way to put something. Oh, where'd that go? I just lost my Discord. Okay. Am I going to get in trouble? It was going to play something. Actually, I can just download it. Oh, okay, it says unexpected. Was that? Is that me talking in the background? Anyway, okay, I'll get in trouble with that. That's cool that you're making a badge. That's pretty cool. So they're the 1.1. That's the Golang mask. Is it? Are these the 10? No, the 1111 LEDs? Golang. Okay. Hey, Mark. Might be running TinyGo. I don't know. The Go far. Anyway. Yeah, sorry, I'm distracted with my TinyWATCH again. Okay, I gotta stop looking at that. Yeah, they're the ones. Forgot the banana for scale. Haha. Okay, I am going to, I think, call it a short stream today, or shorter than normal. An hour and a half in. Yeah, sorry, I am distracted now, thinking about other stuff. Distracted. Oh, I got my new, wait, did I order the wrong size? Oh my god, I ordered the wrong size HDMI connectors. Fuck! Oh no, I ordered mini HDMI. I got new connectors that were shorter feet for my HDMI P mod, but whoops, I didn't look at the size. That's okay. I only ordered 10 of them. Hey, Pro Engineer. I'll show you what else is fun. You know what's fun? I've got to cover that up. It's fun when JLCPCB deliver you panels, yeah? And they forget to route out, actually, let me switch. No. I've got to cover what that is. And, oh. They forget to route out the slots. Look at that. Whoops, missing. All the slots are missing. Isn't that frustrating? So there's hundreds of boards that are useless now. So that was my joy yesterday in being stuck on a client project that I can't now continue with. Unpacked them yesterday and discovered the goodness. And of course they've been away. They've only came back yesterday, but their support staff aren't. Well, I don't know what's going on. Their comment is basically, oh, bad luck. So I've been chatting with. Oh, hello, Peter. So how funny! I was just about to say. So Peter just came in. Peter Homan. Chatting with him, he's going to. I sent him the Gerber files, and he's going to route out all of these missing slots for me, because if I'm already fighting JLC on it, but it'll take them probably, I don't know, 2 or 3 weeks of stuffing me around before they'll even admit that they missed them and they're going to replace the boards, and then it'll be another 10 days or so for the boards to get made and sent to me, assuming that they don't wreck something else. So I'm opting to get someone to route them out for me here. There's 300 boards that need to be routed, which makes me want to go and get a CNC again. Like if I had a CNC here, I could fix it myself. Turned out I forgot to solder the full side of one of the matrix chips. Really? That's funny. Well, right now they don't want to remake them because they're doing the whole, you know, we didn't make a mistake. I mean, they're in the Gerber. They're in the edge rail, the edge cuts layer. In their routing layer, the slots are there. They just didn't cut them. The prototype boards they made, like the single boards that I validated first, they cut the slots in, no problem. Just these ones, they do it all the time. There's stacks of examples of missing slots. No, you build a, I don't think so. Because you use the holes, the hole data on the panel. I think it'll be fine. Yeah, it is this is a client job. So yeah, it doesn't really matter what it's called. Yeah, that's what they go. Yeah, we'll give you a $5 voucher. Yeah, I mean, they're just, you know, I've said it before, they really don't like taking responsibility. They drag it out for weeks and weeks hoping you'll give up. And like you message them and then it's like 2 days before they get back to you, and then you reply to them straight away, and then it's 2 days before they reply, and what they reply with doesn't even, like, they just repeat the same thing again, right? It's infuriating. But anyway. Mutant cybernetics, by the way, are you planning to move to more smaller components than the current ones you have capability now? I haven't really had the need to. I mean, I can go super small on the Juki, but going smaller, it doesn't really save me a lot. Like, it increases my manufacturing difficulty in terms of potentials for tombstoning or needing rework and stuff, and for very little gain. Like the size difference in terms of space on a PCB between an 0402 kappa resistor and a 0201 it isn't that big of a difference. And with caps, the smaller you go, the worse they are in terms of tolerance and capability, right? So, yeah, it doesn't really make a lot of sense. Like, I could have gone smaller components on the TinyWATCH to make the board even smaller, but it means that it's not going to be manufactured by other people. That's standard China business. You always have to chase continually. It is hard. Yeah, I know it is. I know. And it's what I'm used to with them. And, you know, the fact is they're still, you know, when there isn't an issue with their boards are great. And they're just that much cheaper. Like for the number of panels and stuff that I get, and for my ability to not have to, you know, pay a massive setup fee or get locked into a design, and my ability to be able to change stuff, I just deal with it, right? It's just frustrating that it happened, you know, and I don't have a recourse with them right now because not all their staff are back from holidays yet. So, like, it's going to take time to, but yeah, I'll get them rerouted. Yeah, I review, like, I don't let anything, no matter what I put in there with them, I review stencil and production Gerbers all the time, which slows things down. Like, I can put an order in on a Monday, and by the time I get all the production files to have a look at and then fix the mistakes, because they make mistakes all the time, which is why I check every single Gerber. By the time I get them fixed and get them to, you know, like, message them back, refuse them, you got this wrong, you're missing this, or whatever, or, you know, and then get them to reissue them, check them again, and then get them put in production. That Monday is suddenly the following Monday. I lose like 7 days, sometimes between 5 days and sometimes 7 days of just losing that whole production time before they can even start. And if you have an order, like, I'll obviously batch my stuff together, so I'll put like 5 things in at once. If there's one thing that needs to be fixed or whatever else before it can get in production, they hold up the whole order. So there could be things that I'm reordering again that don't need any checking, and they won't even start them until every single thing is approved. So it's not like, you know, it could be a simple 2-layer board that they stuff up a stencil on, right? A design, whatever. No, not a stencil, a board design, whatever. They'll hold everything up before they put them in. So anyway, yeah, I want to buy a CNC router, just a small one, not a cheap, crappy, no, like something decent. But anyway, I just don't have time, don't have a place to put it, time to learn, whatever. Yeah, but I'll get there one day. One day I'll do it. Drum roll. No. Well, the Bantam, yeah, that's super expensive. No, I can't even remember the name of the ones that I was looking at. Let me see if I can find it. So much for stopping the stream earlier. I'll find it. Hang on 1 second. That's right. It was an Mio. Right, it was one of these that I was looking at. I can't remember which one. I think it was the 220. I think it was this one. The 220L. So something like this. I want something that's sturdy, gantry wise. No, nothing like that. I don't want to make PCBs. I'm not interested in trying to make it like an actual PCB with it. I want something that I can just do general. I want to be able to do metal as well as, you know, potentially route. And I want something that's open like this so that I can like build a vacuum bed for it or something. Like, I don't want something that's in an enclosed thing that I can't get in there or underneath. Doesn't need to make routers. I don't know. Maybe Charm High do. Yeah, I want something. The problem with the Nomad is they're really designed for wood. Like they can cut some thin metal, but they're all of those are designed really for wood-based routing, where these can do metal quite easily. So something like this, but it's, you know, they're not hugely expensive for a router. Like I don't need 4-axis. So $27.99. But anyway, one day. I go on, you know, start looking at routers again, you know, for a couple of weeks or you know, a month, and I'm an R and put something in my shopping cart and then never buy it, and then suddenly 6 months has gone past and I go, oh, really could have used a router, and I start the process again. But I'm looking at this through recommendation. No, I want to be able to enclose it, but I don't want one that is enclosed, like the Nomad, for instance. Like, what are they called? What is the name? Name of the company, I can't remember. Carbide 3D, right? So the problem with the Nomad is, like this, is, where's a better picture of it? Because it's enclosed, I can't mod it. Not easily, right? So I agree that it needs to be enclosed when I'm working, but it can be enclosed in a cover, in a box, in a shell that gets taken off. You know what I mean? Like I can't stick a vacuum bed in this. And if I can get a vacuum bed working with a custom vacuum bed frame type thing, then I can potentially separate my boards with the CNC. Add a dual motor to the Juke. Yeah, I'm not sure that's a good idea. Doing any type of drilling.
Cian, chat has disconnected.
Okay, reconnect. Good. Yeah, I want to. I don't want to be drilling in the Juki and generating debris and dust and crap in there. And like the Shapey Okos are like they look really good, but the problem with them, again, these are really designed for wood cutting. I don't need something quite this big. Was that? No, it was just I don't know what voice it uses for that. So these came recommended to me by a few people that are using them, and they're cutting, you know, aluminium. They're cutting thin steel with them. Really rigid apparently, and really good. So that's what I was thinking. Is I want something that can actually do that if I want to machine parts, even some basic stuff. So that's what I'd probably be looking at. But I just, again, I'm not going to buy one just to fix this problem with the router. I'll do that with Peter. Thanks in advance, Peter. Thanks in advance, Peter, for not destroying my panels. Maybe even, yeah, make a watch case that isn't 3D printed. Who knows? But it's not on the cards right now. Even if I get one, you know, the learning curve is huge, and I just don't have the time for it. Okay, folks, I'm ending the stream. I'm going to say goodbye. Thank you all for watching. Yeah, and I hope you all have a fantastic week. Maybe Tanky next week. We'll see how we go, if I can solve those problems. Yep, have a great week, everyone. Catch you later. Bye.